By studying water in all its forms, the Aqua satellite gives us insights into things like the complex nature of our atmosphere, helping us understand our day-to-day weather and our long-term climate. One instrument on Aqua, the Atmospheric Infrared Sounder, or AIRS, has given us phenomenal new science and practical applications with its three-dimensional view of the atmosphere.
When we started with AIRS on Aqua, we had two goals defined to us, before the mission started. One, provide data to the nation's weather forecasting center, which is NOAA, and improve weather forecasting.
We all know that weather forecasting is never perfect, but scientists continually work to make it better, and the AIRS instrument on Aqua has played a key role. By peeling back the layers of clouds to see the dense water vapor hidden within, the AIRS instrument has helped NASA and NOAA models improve weather forecasts by 6 hours. Seeing 6 hours further into the future doesn't just help improve our weekend forecast. It can make a big difference to all kinds of businesses, shipping, aviation, and agriculture.
So that was the first goal achieved, and we, the science team, felt good. The second goal was improve our understanding of the climate system, the water vapor. That is the main mechanism by which weather and climate is formed here on Earth.
The AIRS instrument actually does more than look at water. It studies gases in our atmosphere like carbon dioxide, which is crucial to understanding natural and human-induced climate change.
The AIRS carbon dioxide data have generated particular interest because of carbon dioxide's role in the greenhouse effect, allowing the sun's radiation to come through the atmosphere easily and reach the Earth's surface, but blocking some of the Earth's radiation from getting out to outer space. Carbon dioxide is not the most abundant of the greenhouse gases. Water vapor is the most abundant, but carbon dioxide has generated the most interest, and that's because carbon dioxide is the most abundant of the greenhouse gases that humans are known to be impacting significantly. We know that humans are pouring carbon dioxide into the atmosphere through industrial activities, and also that some of our land use changes are affecting the amount of carbon dioxide in the atmosphere. The AIRS data, in addition to all their other uses, are now allowing us to monitor on a global basis the changes in atmospheric carbon dioxide.
Every year, plant life on Earth takes up carbon dioxide in the spring, causing an annual fluctuation of CO2 in the atmosphere.
The AIRS data show the seasonal cycle really well, and they also show that every year as the carbon dioxide amounts rise and then fall, they rise to a higher level and don't fall quite as low as they did the year before. This shows that there's a prominent long-term upward trend, and this trend is in large part due because of the carbon dioxide that's being added to the atmosphere through human activities.
The AIRS science team has learned that it takes CO2 emissions a year or two to become well mixed in the atmosphere, much longer than previously thought. They've also learned how the movement of carbon dioxide around the globe can be related to weather patterns. And they've even discovered unexpected sources of emissions.
You look at the carbon dioxide in the northern hemisphere, yes, you have industrial nations, industrial areas, from the USA to Europe to Asia, you name it, and we see it. Yet we were able to see a very strong band of carbon dioxide in the southern hemisphere. Where is it coming from?
The emissions turned out to be coming from specific regions in South America, South Africa, and Australia.
You put all three together, and all of a sudden we have discovered that there is a large belt of carbon dioxide in the southern hemisphere, never discovered before.
AIRS has proven to be a versatile and robust scientific instrument, changing the way we think about our climate and improving our weather forecasts.